Okay. Good afternoon, everyone. On behalf of agricultureinformation.com, I'd like to invite the speaker, Mr. Riddhish Soni, who will talk about AI-enabled aquifer mapping. I now request the speaker to begin. Thank you.
Thank you, ma'am, for giving us this wonderful opportunity. So, I'm Riddhish Soni, founder CF Aumsat, and when I was working for the Chandrayaan 2 mission, I was tasked for finding water on the moon. So, like, I went back to the history, back to the time, and read about other space missions, such as we know all the space missions, such as Neil Armstrong landed on the moon in 1969. And after the landing was completed by the Apollo missions, the next question was like, can we establish a civilization on the moon? So I think the most important question over there was, what do you actually require to establish a civilization? So first is you require water, and second is you require atmosphere. So since there is no atmosphere on the moon, water was the only like option, which was successfully tried to be discovered by couple of precursors, but unfortunately there was no success. In the year 1994, there was a US spy satellite named Clementine. While it was orbiting and it was past its completion phase, so NASA decided to kind of use this satellites and sensors for its application on the moon. So this satellite was basically equipped with a radar, and when the satellite started to take the images of the moon, they could see certain amount of water signals present in the northern and southern regions of the moon, which is called as the permanently shadowed regions of the moon. So using the same technology that was used to discover water on the moon, Chandrayaan 1 was the first satellite which confirmed the presence of the water on the moon. So it is said that Chandrayaan 1 is the first satellite that is used to detect it. And well, I was part of the Chandrayaan 2, so I was told whether this water is we have to continue the discovery of Chandrayaan 1, and also say that what kind of water is present in the on the moon. So basically, there is the water is not in the liquid state. It is in the form of ice, and it is in the form of hydroxyl ions. It is either magnesium hydroxide or calcium hydroxide that way. And coming to that, basically the satellite is able to penetrate in the subsurface and detect these signals. So I said, why not use the same technology for helping farmers? So in 2019, we founded Omsat, which is like at Omsat, we are a smart groundwater management system focused on reducing the uncertainties of farmers and helping them optimize the energy, water use efficiency, and economic losses associated with irrigation. So I'm trying to bring it to the next slide. Yeah. So the problem so I belong to Maharashtra, and in Maharashtra, I saw a very big market gap in the fact that traditionally in India, people use coconuts and twigs for finding groundwater. In case they do not find water, which in the majority of the case they do not, they still have to pay around $1,500. That is equivalent to 1.25 lakh rupees or 1.5 lakh rupees at present market rate to go for a direct hit and trial drilling. And in this case, if you see that whenever there is a water scarcity, it triggers a food crisis, which in turn creates a migrational crisis. So it's a kind of a vicious circle. Whenever there is water crisis, there is a food scarcity, then migrational crisis. So in the year 2023, as we can see that 50,000 farmers in Marathwada region of Maharashtra, which is covering 8 districts, were migrated from rural to urban, thereby increasing the stress on the urban resources. So we wanted to like bring a kind of a transparency in the method that or how you can actually use a scientific technology for finding groundwater. I'm not saying that there are no methods present for the same. There are a couple of techniques used for groundwater exploration, but in terms of speed, resistivity survey methods, it takes minimum 4 people to do the survey, and then you have the transient electromagnetic survey, which is done by kind of a helicopter. So there is a system which is mounted on the helicopter, and the helicopter goes and does the survey, and then you get the data. So, but transient electromagnetic, the problem is it cannot fly over electric cables, and basically you have to kind of take too many permissions to fly it. So, for example, one system, if you want to get it deployed something over a desert, it will like take pass a single scan would be easily summing up to a sum of around 60 crores. That is the cost. And resistivity survey, like you have to, it's a very time consuming process. But when you talk about like the Indian subcontinent is divided into like hard rock and like so basically two-thirds of the Indian subcontinent that is lying below the Godavari, sorry, then below the Narmada, south of Narmada, it's called as Marathwada. That is water propagation takes place. And no, everything north of Narmada is relatively the Indo-Gangetic plain. So there, the type of soil controls the movement of water. So India is like kind of divided into these two, different kinds of geologies, and every technology has its own pros and cons. But when we talk about comprehensive groundwater management, we provide services for groundwater conservation. That is where to detect the suitable sites for construction of recharge sites, towards monitoring the groundwater over exploitation, where exactly the over extraction is taking place in a specific region, to groundwater targeting and exploration, that is telling the farmers how much water you have, what is the yield of water, and whether there is water in the first case or not. And then we have an borewell inspection robot that goes inside the pipeline and does the internal mapping. And then we have other solutions for groundwater treatment, that is removal of scales that is coming from the groundwater. So, as I mentioned, like in by using advanced earth imaging techniques, we monitor the changes in the phase angles of permanent markers, which is an indication of the over extraction of groundwater taking place. So this over extraction basically is an indication of like how the farmers can judiciously, utilize their water, or in areas where over extraction is being done, how policy can be implemented to reduce the extraction. So this is one of the case studies that we had done in the part of Sajanskar, that is part of Rajasthan, where the kind of a crater had been, like there was a subsidence and a big crater had been created because of the over extraction. So what was the horizontal, what was the vertical extraction of the, how did the entire over extraction take place, is something that we kind of monitor and measured using the satellite observations. And we could also understand, like over the years from 2002 to 2000 like 23, what was up from the last 23 years, how the groundwater table was decreasing. So by correlating these two, we could actually see the series of events that took place, how the over extraction did. So this is a publication from the Jal Jeevan mission in September 2024 that we did it. Then by using a combination of C-band radar and L-band radar, we are able to detect we carry out a technique which is called as multi-frequency radio interferometry, that is able to give us the exact quantification of the yield of water that is present in the subsurface. So this is our publication for March 2022, where we had detected a river and a paleo channel, that is our subsurface river, using the kind of technology talking about the L-band radar. And then like finally, by using a combination of Daiichi and Hivamari satellites, where Japanese satellites, we are able to estimate the optimal sites for construction of recharge sites. So what is the direct direction, like what is the dimensions, and what scale the groundwater recharge site can be done adjacent to a borewell, so that extraction and recharge both goes hand in hand. So basically, we kind of calculate like the area, and we calculate what is the like basically what is the measurement of the area. So multiplied by, there is a kind of a Q equals to Ci, that is giving us the amount of surface runoff that is taking, or a runoff coefficient that is taking place in a specific piece of land. So from that we can understand which is a recharge zone, which is a extraction zone. Then, so this is one of the case studies that happened. It's a very interesting story. There is a place called as Mavalgaon in the like this district of Latur, which is coming near Ahmedpur. So there in the last 60 years, there were no bore wells, and so we were the first ones who came up with this technology and detected the first bore well. And not only we detected the bore well, so here in the image that you can see, the blue is giving us the strong signals from the satellite where the water is present, whereas red areas do not have water. And talking about the source sustainability means how we can trap the water so that like India gets good amount of rainfall, but we are not able to harness it because it is all the water is like diverted through runoff and ultimately it lands somewhere else. So we are not able to capitalize on the amount of recharge, which is a big problem for India at the current situations. And this is a publication that we did with Jal Jeevan Mission in September 2024. And the farmer who got the water actually, he took it inside a pot and walked barefooted from all the way from Latur to Mumbai. So that is the power of faith when you talk about creating an impact for the farmers. Recently, did a couple of we created 122 recharge sites in the Mehowal Arcade and Chandrabani, that is western part of the Dehradun city in Uttarakhand. So where we created such kind of structure so that all the rooftop rainwater and the storm water can be diverted towards the injection wells, and this water can be able to. So here you can see we are also able to detect what is the direction of the groundwater, and this is a publication with Deloitte Tomatsu and JICA. So currently, like we believe in channelizing our impact to the smaller farmers by creating strong and strategic relations with national and international organizations. So currently, we are working with World Bank, JICA, Asian Development Bank, World Food Program, United Nations, and we have worked with a couple of countries globally, including Iraq, the Karbala city of Iraq, where we detected the over extraction. So, since 2019, we have created more than 3,800 water points, scanned around 44,000 hectares of land, and recharge almost 17,000 kiloliters of water per month. And in India, we have the clients such as IndusInd Bank, ICICI Bank, Ministry of Housing and Urban Affairs. We are empaneled by three ministries in India, with the Ministry of Agriculture and Farmers Welfare, Ministry of Jal Shakti, Ministry of Agriculture's and Minister of Housing and Urban Affairs. So, talking about groundwater detection, there are a couple of technology that is able to detect the groundwater, but research has given us the ability to have predictive analytics. That is, how is the groundwater table going to be like for the next couple of years? So that is something that is makes us unique. And talking about like groundwater availability, suppose a farmer has water and suppose a farmer doesn't have water, how do we create a kind of win-win situation for the water seller, water buyers, and control groups through a kind of a informal but legally structured hydrosocial contract so that it can create a win-win situation? And how do you kind of manage the shared water resources between two individuals? So we can like either connect one borewell with another farm using a pipe network, or we can if the section is too long, but between the this distance between two fields is long, we can do it by transporting the water through tractors or something like that for the farmers. We are also empaneled by this empanelment with the Jal Jeevan Mission as well. We did a couple of projects with drought hit areas of Latur, Nanded, and Osmanabad, where like in Osmanabad the situation was very dire because they get very scanty rainfall, and it is the important part is like how do you channelize each and every drop of water inside the soil. So that is one of the important factors over here. So these are some of the projects that we did in the drought hit areas of Amangal, Warangal, Kazipet, that is in Telangana. And we also kind of organize farmer water marches. So this is one of the events that we had with farmers and FPOs of Vijayawada in Andhra Pradesh. So we did a kind of water, and we explained them the importance of recharge and how they can leverage the technology for groundwater extraction. So we are a team of scientists, engineers, and big thinkers passionate about making ideas accessible and actionable. having been trained by ISRO, NASA, UNOSA, Google, and Harvard School of Design, our consistent foundations are built on precision, innovation, and trust. Here are some of the awards that we have got from the Israel government, Singapore government, UK government, Japanese government, and also with the winners of the National Startup Awards. And in other cases, to solve problems such as groundwater, availability. Like groundwater availability is one part, and groundwater treatment is another part. So we created a magnetocatalytic and hydrocotation and ion exchange chamber for improving the quality of water. So this is our NABL certified report from the UP Jal Nigam in Lucknow. And we remove the scales inside the pipelines and inside the water by using such kind of technology that can kind of use high pressurized water to do it. Also, this is one of the other technologies that we have. Like we use a borewell robot that goes inside the pipeline and does the internal inspection for doing what is there is a intrusion, or whether there is algae detection, illegal connection inside a pipeline, crack detection, or rusted connections are there. So this is one of publication that we have done. It is using the movement of a snail. Basically, it's using the concept of biomimicry to propel ahead without using any source of power. So yeah, this is my presentation. Join us in making the groundwater infrastructure of India resilient and sustainable. Thank you. Yeah.
Okay. Thank you, Mr. Riddhish, for the presentation. Now I will quickly take up some questions. Yeah. First question. Yeah. First question is, how does AI help in identifying and mapping underground water more accurately?
Yes, so basically, like I can give one of the situations like before our intervention versus after our intervention. So I can showcase, I mean, I can give this answer through the dashboard that we have on one of the case studies that we have done. So, yeah. So this is the city. So sorry, this is one of the towns, which is districts, which is called as the Banda district of Uttar Pradesh, where it's basically a water scarce zone because it is coming under the Bundelkhand region, which is bordering the state of Madhya Pradesh. So the kind of technology that existed before we came was they used to do random hit and trial drilling, or they used to call those coconuts and twigs for doing the chrono detection. So now I'll show you how does the AI work in this kind of aspect. Basically, when you talk about the boundary, this is the boundary of the district. So we first utilize the C-band radar. So C-band radar is a European Space Agency radar, which is working at 5 centimeter penetration of depth. So here you can just see a river is there over here. Here you can see the town of Banda is there. You cannot see like anything which is further than 5 meters. But when I utilize the satellite, which is called as a L band, it is able to penetrate up to 30 meters into the depth and also detect the subsurface river that you can see over here. So here in the normal Google image, it was not able to see. Even in the C-band radar, it was not visible over here. But when I use the L-band radar over here, you can see the crack and the river very distinctively. And what you do is when we apply the water detection algorithm, so it is able to give us the entire subsurface water resources for the entire 50,000 hectares of land. And say like if you want to do it manually or using the equipments, it would take you easily up to 5 to 10 years. So we are able to reduce the time effectively by doing the entire stitching and creation of the image within a week's time. So you bring down 5 years of work down to 1 week. That is the power of AI.
Okay, right. Next question. How can farmers use aquifer mapping for better borewell planning and groundwater management?
Yeah, so basically, if there is a farmer, like he gives us location from WhatsApp. We can tell him where we can schedule the satellite pass on his land, and then we can tell him whether he has water in the field or not. But finding water is not just the only problem, because ultimately it's finding what is the quantum of water, which is more important to the farmers. So we basically, the satellite is able to go to a greater depth and detect those cracks and fissures through which surface to subsurface water propagation takes place, and whether these cracks are filled with water or not, it can tell us. So the farmer is able to make the decision whether, based upon the availability of water, he should actually go, because economics matter a lot over here. Suppose if you get half inch of water, that is 900 liters per hour, it is not economical enough to go for drilling, because it's like the cost of drilling is somewhere around 1.5 lakhs. So if you are only getting a small quantum of water, you better buy Bisleri bottles with that amount of money. So it's all about economics.
Okay.
Yeah.
Next question is, what data sources, that is satellite sensor surveys, are used in AI-based aquifer mapping?
So basically, we use the L-band satellite which I mentioned over here. It is a Japanese satellite, so which is able to penetrate depth of 30 meter in dry soil.
Okay. And how reliable are these technologies in predicting water availability and recharge zones?
Well, yes. So depends upon the. So it is not about the satellite. It is about what algorithms you are applying upon the data that is received from the satellite. So satellite will only give you like a image of a particular area, but what information that you can extract from the image, and how quickly you can do the processing, and how accurately you do the processing, is very important. So the amount of area that we are working at a very high resolution data. Firstly, this satellite is a that satellite data, so the cost is somewhere around $70,000 per year. And also the fact that the algorithm that we built, it is able to extract the right amount, like it is able to detect what is the exact amount of water spread across a specific zone that we have identified and targeted. So it is the power of the algorithm that determines the accuracy. And as far as our algorithm is concerned, we have already like it's a patented technology, plus we have kind of certification and licenses from the Ministry of Jal Shakti as well.
Okay. And can small farmers access these services at an affordable cost?
Yes, so in fact, this technology was only built for the small farmers, and the currently we are offering our services at 3,300 rupees per acre. So that is a fixed cost that we charge to the farmers, and which is very reasonable for the farmers, because rather than spending 1.5 lakh rupees on a failed borewell, it's always important to get it done from us, so that we can, at a very, very affordable price, they can ascertain whether they have water in their field or not.
Okay.
And in
And
case they do not have
mm,
water, we can also, as I mentioned, we can kind of search the nearest source of water that is available from the satellite, and then kind of, you know, create a hydrosocial contract, so that the water can be brought to the users at the right side. And secondly, if there is no water in many of the tough terrains that we have worked so far, so the fact that we create injection wells, so that they can divert all the rainfall water inside that well and utilize that water during the dry seasons.
okay. And how can aquifer mapping help in reducing borewell failure rates?
Yes, so borewell failure rates initially, as we mentioned, that we it is generally done using coconuts and twigs. So that is a very unscientific techniques which is called as water dowsing. In like Marathi, like we call him those people as panadi. So it has actually lost, because what happens is that whenever a farmer goes to apply to the banks for borewell loans, the bank usually kind of denies them, the fact that they know that if the borewell fails, then they would be accumulating non-performing assets in the form of dry borewells. So but still, like the banks have some pressure from the district magistrate's office in many of the parts, since the farmers have that kind of political connect over there. So they give loans to the farmers, and in most of the cases, when they're not able to find the water, they ultimately, I mean, even they generally go the like are uh, they defaulting, and banks are at a big loss. So from 2009 to 2023, the total amount of these kind of non-performing assets had resulted in a loss of 20,000 crore to the Indian economy. So the borewell rates are very high, and the beneficiary was the borewell contractor, means the drilling company which was charging farmers even if they were failing to find the right source of water.
Okay. And what role does technology play in rainwater harvesting and groundwater recharge planning?
Yes, so what we say that recharge and extraction should go both hand in hand, because specifically talk about all the regions that are south of Narmada River. So you have Maharashtra, Telangana, and all the states that are below that, that are under the influence of hard rock. The only place that you can find water in such kind of cases is through these horizontal and vertical cavities, fractures, where water is like present, and if you start extracting water from this cavity, it is going to get over soon. So what you do is you create a kind of a balance between the recharge and the bore wells, so that the extraction and recharge can go hand in hand. So also we have done a couple of case studies with Telangana, where we utilize the stormwater drainage of universities to divert that water into the recharge shaft, so that a good amount of water can be put inside the subsurface, and whenever required, we can utilize to extract it. Overall, then we saw that there was a gradual increase in the groundwater trend when we saw it from a time series data. Yeah. Oh, I think your this thing was on mute. Oh, hello. No, I think you're on mute. I'm not able to get your voice. Hello.
Yeah,
Hello. Yes, yes.
yeah. So, are there any government programs or collaborations supporting such technologies?
So it's like government is promoting awareness campaigns that you should save water. There is the Jal Jeevan Mission, which is able to tell you that there is every house in India should have a kind of a tap connection. But problem is that with governments, it is always the question about what is the accuracy of the system. So for example, we have done projects with Gandhinagar Smart City, we have done with JICA in Uttarakhand. So the central government, the Ministry of Housing and Urban Affairs, supports us for our interventions in the city perspective. But when you talk about the rural areas, the question is about like how the Ministry of Agriculture is able to push these initiatives ahead. And see, Ministry of Agriculture does support these kind of programs. So they have the program which is called as the RKVY Raftar program, where they are supporting startups who are into working into irrigation and water management for farmers.
Okay. And What infrastructure or support is needed at the village level to implement these solutions?
So the fact that we found that our major go-to-market strategy was like using so the farmers they are a very different like they have a different mindset from the people who are living in the urban areas. So for instance, it is not that you are advertising using digital marketing and the farmer will be able to adopt it very quickly. Farmer has to see a lot of aspects because he's bounded by so many decisions that he has to take in a very short span of time. So what we observe that in terms of uh, economy of scale, like the solution should be cheap and it should be able to accurately detect the and serve their purposes. So if you are able to install that kind of trust, the farmers will like kind of, the entire village becomes yours. If there is one case study which is able to give you that amount of success. But when you talk about something like talking about the trust factor now. So a farmer, say, living in the same district may not accept. Suppose, see, if you there is one farmer staying in a place called as like say Connaught Place in Delhi, and another farmer staying in another part of Delhi, which is called as say Gurgaon. So if you have done your case study near Connaught Place, the farmer in Gurgaon will not accept it because he's like that is a different geography. Like it is doesn't mean so whether you have done in my place, someone I need that kind of confidence. So in order to do that, from the support of the Ministry of Agriculture, we created around for every district of Maharashtra, we created in every block of Maharashtra, we created one case study. So whenever I kind of click on any kind of coordinate, I can give you what is the name of the village, what is the depth of the aquifer, and what was the level of the water, and when did we do the analysis. So that way we have that kind of data for the entire Maharashtra in that second. So since we have able to demonstrate our effectiveness over the entire block and each and every block of the state, then any farmer comes to us, we can say that this is a reference that you can take in case you need to do cross verification. So once that trust factor is being ascertained, people to comment, and we also have awareness campaigns with NABARD. Every month they have a FPO meeting, and the head of FPOs they're connected thousands of smallholder farmers. So that's how we do the awareness campaigns. So NABARD is very much active into this role.
Okay. Uh, Now I think we have the last question once again. What future advancements can improve precision in groundwater mapping and usage?
So, talking about technology is already available, but when we talk about execution, because just finding the point is not important, you have to actually call the drilling surveyors, even the water, after the water has been found, you have to do the casing, piping, pumping, bringing the electrical connection to the field. So there are a couple of the big value chain that you need to ascertain over here. And talking about recharge, that every farmer the biggest challenge that we have presently is the farm land holding is getting divided. So one farmer who used to have around 10 acres of land before, now his children are having half an acre or even lesser acreage than in their name. So now these farmers want that water should be shared equally. So
Hello, Mr.
it
Riddhish,
is,
you are there? Yeah.
yeah, yes.
Last line I could not hear.
Yeah, so basically, whenever there is one groundwater and in future after 10 years nobody has water, so there is a talking about Haryana, the entire groundwater is showing a negative trend. So such kind of situation should not happen in India. So the emphasis should be there on how judiciously we utilize the water and how effectively we manage the recharging component which is associated with groundwater.
Okay. So before we wind up, one last question. Please let us know a little.
Uh, Ma'am, I couldn't hear you. Can you repeat the question? Hello. Uh, Hello, ma'am. Am I audible? Hello. Hello. Ma'am, I'm not able to get your voice. Hello.
Hello.
Hello. Yes, ma'am. Hello, ma'am. Your voice is not audible.
I can hear.
Uh, Sorry, ma'am. Your voice is breaking now.
Hello.
Yes, ma'am.
Okay. So before we wind up, one last question. Please let us know a little about your career background and what made you to start this company.
Yes, yes. So, working in ISRO, I was part of Chandrayaan-2 mission where I saw two states of India. One which is highly developed, that we have reached Moon and Mars, and very technologically superior technologies I have seen implement in the best research organizations, including ISRO, DRDO, and the top CSIR organizations in India. The problem with these technologies was all the knowledge used to be stashed inside the library. So these technologies never got the opportunity to come out and utilize like the implementation part, as we said, that who is going to do the execution. You have the technology, you have the algorithm, but um, how do you actually utilize these for the benefit of the pyramid? And talking about the bottom of the pyramid, it's like the farmers. Most of the time when I go to Marathwada, uh, the I see poverty. I see like the development hasn't yet reached to many parts of the India. The fact that if we can utilize the technology that is used to discover water on the moon to help some kind of farmer in remote location such as Marathwada, that could actually bring that kind of impact to the grassroots level impact to the India. So that was one of the reasons that motivated me to leave the organization and start like looking for my own purpose in life, that is to make a larger impact to the sustainability in terms of the resources that are available to us. And then we hyper localize this technology from aquifer detection to recharge, and then also using the same technology for detecting leakages in water pipelines. So we did that project with World Bank, GIZ, KfW Bank, etc. And now that initially the technology that was used for destructive purposes, that is destroying the aquifers, is now being used for conservation efforts to find the right set of underground water resources, and then how do you kind of preserve these natural resources for a longer period of time. And so this has been my journey so far.
Okay. Okay, Mr. Riddhish. So
Yeah.
I don't find any more questions. So
Yes.
now we have come to end of question round. On behalf of agricultureinformation.com, we'd like to thank you for the presentation and answering all the questions in depth.
Yes.
We'll be ending this meeting now.
Sure.
Have a good weekend ahead. Thank
Yes.
you.
Thank you. Yeah. Thank you.